I thought this week would be a good week to do our lecture on scales, and let me get this into full screen mode so you can see it a little bit better. You should have two scales. You should have an architect's scale and an engineer's scale, and we'll look at both of them. These are three-sided prism-shaped tools to give us the most usage out of the scales themselves. And there are basically two types. There's a fully divided scale and a partially divided scale. Your architect's scale is partially divided. In other words, similar to this, it would only have the smaller divisions in the end of the scale, and then it goes to full division. So if you were scaling in 1 foot increments for the architects, then the smaller divisions would indicate inches or fractions of inches. The engineer's scale, by difference, is in base 10, so they fully divide it. Most scales would look something like this, but they're divided all the way to the end. This engineer's scale happened to be in eighths, so it's not really a true engineering scale. It should be divided in divisions of 10. So we'll take a look at some of these a little closer. Here's your prism-shaped scale from the end view, and what we see here is an architect's scale. The architect's scale, this scale, they read from both directions. So on this one, from this direction, it's 3/8 of an inch equals a foot. So if we were to look closely at this, we'd see that these smaller divisions are set up in, this would be 1 inch increments. You can see 1, 2, 3 to this point. So there's 3 inches, 6 inches, 9 inches, 12 inches. So it makes a foot. So it's in divisions of 12. So if I were to place a line from, say, this point, it would be 1 foot, 2 foot, 3 feet, 6 inches if it came to the middle. So you can see that we're reading these things kind of backwards from what they normally would read out, and we'll see it when we look at our full scales. On the bottom of this one, you have 1.5 inches equals a foot. So this would be 1 foot, and you can see these are broken down into smaller segments because it's a larger scale. We have 1/4 inches, so there would be 1/4 inch, 1/2 inch, 3/4, and 1 inch. And all the big marks are 1 inch, so there's 3 inches, 6 inches, 9 inches, and a foot. So from this point, or from this point to this point, would be 2 feet, 3 inches. If we were halfway in here, we'd be 3.5 inches. The way you utilize these scales is you always put, if you were measuring a line, you'd put it to the nearest whole number out here, with the remainder falling somewhere in this zone, or this zone if you're in the 3/8 inch. So you're trying to just lay that on the line so that whatever's left over falls in this area. Another example down here is your 1/8 inch equals a foot. You can see that our divisions are much smaller. We only end up with 2 inch increments on the 1/8 inch. On the 1/4 inch equals a foot, which is on the opposite end of the 1/8 inch. And just as an example, on the opposite end of the 3/8 of an inch would be a 3/4 inch scale. 3/4 of an inch equals a foot would be shown on the other end, so that these scales are versatile enough that if you've got 4 scales on each side, you actually end up with 12 scales total on an architectural scale. The fully divided on the engineers, you will see that they only read from one direction. And down here we have 1/2 inch equals a foot. So the distance, the actual distance from here to here on your scale is 1/2 inch. The distance from here to here is 1 inch. So you can see this dimension from 2 to this point would be 2 feet 8 inches. So the trick again is put it on the whole number and let whatever falls off on the other side. Here we have our fully divided engineer's scale. And the nice thing about the engineer scale is it's very versatile. We only have one scale here. It's a 10 scale. Down here would be, if I can figure it out, it's probably it's probably a 50 scale on the bottom side. And by the same token, your metric scale is similar in that it is also a base 10 scale, but it uses centimeters as its base rather than inches or millimeters. So this distance from 0 to here would be 1 millimeter. This is 1 to 200, so this would be 5 meters. If 1 millimeter equals 200, this would equal, or 1 to 5, you can see there's 1, 2, 3, 4, 5 divisions here in the metric scale. So we got millimeter, centimeter. But back up on the engineer scale anyway, this distance from 0 to 1 is exactly 1 inch. So with this one, we can just place the 0 at one corner or one portion of the line segment, an end point, and wherever it falls. So this, if this was 1 inch equals 10 feet, then this would be 10 feet, 11 feet, 12 feet. It's a full scale. So you could, this just reads 1 inch, but it's in 10. So let's imagine if this is 12 feet at 1 inch equals 10, I can also use this scale to say 1 inch equals 100 feet. So this would be 100 feet, 110 feet, 120 feet. I could also say 1 inch equals 1,000 feet. So this becomes 1,000, 1,100, 1,200. So we're able to interpolate many more scales with these by just multiplying or adding an additional decimal point, or removing an additional decimal point to interpolate them up. So the 10, 20, 30, 40, 50, 60 parts per inch can also be 100, 200, 300, 400, 500, 600, and also 1,000. Or you could do it just as 1 inch equals 1 foot and use it as a, so this would be 1.2 feet. If I used it at 1 inch equals 1 foot, there's 1 foot, 0.2. So it's easy to interpolate. Now, here's a drawing that I put together, and we'll have some quizzes. So on the top we have our civil scale, and on the bottom we have our architectural scale. So what we'll do is go through some examples, and I'm going to put a homework assignment in there for you to work with and come up with some answers. So let me, I'm going to hit escape to get back into this mode, and we'll draw some lines on here with my little line tool. And we'll start with our, hopefully I can zoom in on this. There we go. Yep. I have to go back, tools, line tool. So here's our 10 scale. If I start a line from an endpoint here and bring it across to, let's say, this point. At 1 inch equals 10 feet, this would be 60, 61, 62, 63, 64, 65.5 feet. At 1 inch equals 100 feet, it would be 655 feet. At 1 inch equals 1,000, it would be 1,550 feet. And again, it only reads in one direction. Here we have a 50 scale. So you'll notice on the 50 scale, if we line this up down here, that this lines up with the 1 inch mark. So it's divided an inch into 5 segments to become a 50 scale. So if we put a line from 0 and we measure it all the way out to this point at the 40, this would be, so you could say 50 feet. There's 50 feet, 100 feet, there's 200 feet, 300 feet, 400 feet. So 1 inch equals 50 feet would be 400 feet on that line. Could be 4,000 feet. Could be 40 feet. You're going the other way. So this would be 10, 20, 30, 40 feet at 1 inch equals 50. It depends on what the scale is asking you for. 20 scale, you'll notice the relationship here, 0 to 1, this equals a half inch, and 2 would be a full inch. So this could be used as a half scale if you're working in decimal format. So a line from this point, whoops, let me just grab that. Okay, so I'll move it up out of the way. There. So we'll start at 0 and just come out here to this point. 1 inch equals 20 feet. This would equal 15, 16 feet if this is 20. Could be 1 inch equals 200 feet, where this would equal 160 feet. Or 1 inch equals 2,000 feet, where this equals 1,600 feet. So if you're looking at a map, it's easy to use these. Opposite side, we've got a 40 scale. Bring it out. We'll bring it right to 18.5. So this, and you notice now we've got 4 segments per inch. So now this would equal 40. There's 50, 150, 180, 185. 185 feet on a 1 inch equals 40 scale. Keep in mind when we're drawing on the computer, we draw everything at full scale. If we're drawing a line 40 feet long, we draw it 40 feet long. Even though it may only appear 2 inches on the screen, it's a 40-foot long line. And when we bring that into our sheet view with our title block, that's when we scale it down. So when we get done with this, I'm going to go through a couple things that we're going to be using in our current exercise, and maybe I'll bring that up on the screen. But again, the 30 scale is the same way. You'll notice that where the 3 would end up here actually lines up with the 1 inch mark. So this is divided into 3 segments per inch, 2 segments per inch, 4 segments per inch, 5 segments per inch, excuse me. Now let's look down here at the architectural scale. All 3 sides, I've scanned this and put it in. So on the architectural scale, you have a full scale here, which is divided into 1/16 of an inch. So if you're measuring something out full scale, this would be, whoops, this would be 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9/16. 2 and 9/16 because we have 16 divisions between each inch. This is the only part of the scale that reads just in one direction. Now the rest of these read in both directions. Here's a 3/32 on one end. 3/32 of an inch equals 1 foot. Down here we have 3/16 of an inch equals a foot. So if we were to take this line and move it down, and I find the nearest whole number where what's left over goes down into the divided area, then this would be 13 feet 8 inches on a map. If we take that same line and put it here, we'll move it to the 2, and then what is left over down here, this is 1 inch equals a foot. This same line length would equal, excuse me, this line length would equal 2 feet, about 6 3/4 inches. Now the smaller the scale, the less accurate you are, but you can get fairly close. So 2 feet, 6 3/4 inches. Let's take that line again and we'll move it down. Having a tough time here. We'll move it over here and we'll put it, looks like we have to go all the way out to the 8 to get something left over. So there would be 1, 2, 3, 4. This is 5 feet 1 inch. Because we're reading it from this direction. So between the 4 and the 6, this would be a 5. You just count the segments out. Down here we've got 3/4 of an inch equals a foot. So if I put it on the 2, it's too far. So it has to come out to the 3. And this one would equal 3 feet, 3 feet 5 inches. 5 segments here. So there's 6 inches, there's a foot. We bring it down here, we're going to be right at the 6 without going over. So there's 6 feet, 9, 10 inches, which makes sense because if this is 6 feet 10 inches, that makes this 3 feet 5 inches. Be half as much, 3 feet 5, or 6 foot 10. Down here we've got 3 inches equals a foot, which is your biggest scale. You usually see this using details. So on this one, we can't even fill it. So it only ends up being, there's 1 inch. So if there's 3 inches to a foot, then 1, 2, 3, 4. It gets divided up a little differently. But anyway, this would equal 3 inches, 6 inches, 9 inches, 10 inches, about 10 3/4 inches. If we were, and that would be the actual size. We'll move it down here to the other one. You see this one actually does require a foot. So this distance from here to here is 1.5 inches. So this would be 1 foot, 3, 6, 8. 1 foot 8.5 inches would be that line. Architectural scales are always written this way. On your large scale plans, when we're using civil drawings, we're going to use this drawing because we measure things in tenths of a foot or tenths of an inch, all in base 10. When we're starting into architectural, we know our carpenters are out there with their tape measures. They're measuring things fractionally. So they're looking at 9 feet 10.5 inches. They need to be able to measure that off their tape. And, you know, carpenters don't like to change things to the decimal place if they can help it. I was just reading a manual the other day on children's centers, and the federal government actually makes all of the design elements in children's center are written in metric format. And then you have to convert them yourself, or you have to be able to size them, but they do all their testing and whatnot in metric format. So if we go and take a look, I'm going to close this out now, and we're going to go take a look. I don't want to save anything. At our drawing, I think I probably have one here, and we have a bunch of them. There's a site plan. Yeah, this one looks kind of, don't know how far along it is. Okay, there's our drawing, kind of how we left it. We had some roads started in here. You'll notice if I go to my model view, this is set to 1 to 2. There's an annotation scale here. And I can see that I've got some custom scales. You won't have this in yours. But we can create some custom scales. If I wanted to create a custom scale, I'm going to add one in here, and I'm going to say I want to make a scale that's 1 inch equals 60 feet. So my paper units would be 1 inch. My drawing units, I have to ask the question, how many inches are there in 60 feet? So 60 times 12. If we knew 50 feet was 600, then another 10 feet would be 720. So 720 paper units, or 1 paper unit equals 720 drawing units. So we have to convert things to equal elements. We wouldn't put 60 in there because that would be 1 inch equals 6 inches, or 60 inches. We need to say 1 inch equals 60 feet, so it's 720. Hopefully my math's right there. So we can create these custom scales in our engineering. And if I say okay, my annotation scale I want to say now is I'm going to use 1 inch equals 100 feet. So if we move to our sheet view layout and I come here, I can say I want my scale to be 1 inch equals 100 feet. I have no idea what that just did. I think I have a extra viewport maybe. Must be. 1 inch equals 100 feet fits on there pretty good. And then I would come down here. Whoops, I mean to do that. 1 inch equals 100 feet. And move it into place. I use my middle wheel to move it. And click back here, and I'm going to say my scale now is 1 inch equals 100 feet. So I would type that in. Happy Valentine's Day, by the way. So that's our subdivision. Could I fit this in at 1 to 50? We're going to come back here to our paper, look at our scale, and say, will that fit at 1 to 50? No, it's too big. 1 to 60? Getting better, but really 1 inch equals 100 feet is the best we can do. So if I were to take my engineering scale and I print this out without scaling it onto the paper, I just say none, so it prints out exactly the same scale as I've put it in here, and I put a dimension or a scale from this point to this point, I should read 375 feet. So that line, I don't know whether it's 375 or not, but assuming this was 375, the actual measurement on this line would be 3.75 inches, 3 3/4 inches. We multiply that times 100, ends up being 375 feet. So does that start to make sense to you? And if we go back to our other drawings that we brought in at 1 to 2, any of these scales can be customized. You can see these are all set to engineering scales. If I wanted to put in a custom scale for architectural, I don't have any, I can add one. And I want to put in a scale that's 1/4 inch equals 1 foot dash 0 inches. So 1 paper unit, 1 inch on paper is how many drawing units? Well, we have to ask ourselves, how many 1/4 inches are there in a foot? 48. 1 to 48 is our ratio. Now I've got that in there, I can hit OK. If I wanted to see what this looked like at 1/4 inch equals a foot, we'd see that it disappears right off the screen because it's zoomed in so much. We wouldn't even be able to see it. I could probably move things around. There's a piece of road. That would be a 16-foot wide road. So this distance from here to here we know is actually 8 feet. It would measure if 1/4 inch equals a foot, and that's 8 feet, that would measure 1 inch would be 4 feet, 2 inches would be 8 feet, 8/4 of an inch, or 8 feet would be the actual dimension. Oh, there it goes. I had it wrong. I had scaled it out a little bit. So this distance from here to here we know is supposed to be 8 feet. If we put a scale on there that is 1/4 inch equals a foot, this would measure 2 inches, or 8/4. We'll bring it back to 1 inch equals 100 feet, and now we can easily fit it onto the screen. Sound good? So I'm gonna upload a little exercise sheet you'll fill out for homework, and we'll have a little quiz at your next lab next week after next. So We'll talk a little bit more about scales in the lab, but this is probably a good start. There's really, it's just ratios. That's all you need to think about, is how many paper units are there to how many actual units I want to put on there. And if you use that terminology, simplify it as much as you can, it'll work out for you. Very good. Thank you.